I'm 1B. Today, 511 test the hypothesis for the difference between proportions of two groups. It is a similar topic. Section 9 test the hypothesis for the difference between two independent populations. In that case, the difference between two means, right? But here, proportions. So what is the difference between these two topics? Let's see. Okay. Test the hypothesis for the difference between proportions of two distinct groups. Instead of means, now we're dealing with proportions. What is proportion anyway? Proportions is from the population of Bernoulli distribution. Okay, so let's see. Hypothesis testing is also possible when examining whether there is a difference between the proportions of two groups. For example, we might ask if there is a difference in support rate for a candidate between region A and region B, or whether there is a difference in the flu infection rate between those who received a flu vaccine and those who did not. Okay, this problem is similar to the one previously discussed regarding whether there is a difference between the means of two independent groups. It is similar, but there is, I think, a difference. However, since we are dealing with the proportions, the distribution of a population follows a Bernoulli distribution. You remember Bernoulli and the proportion, okay? The issue of testing the differences in proportions between two groups, this topic, okay, is a means to check how well you understand the material covered so far. So it is what concentrated topic. So you better keep in mind the previous your knowledge. Let's denote population 1 and population 2 as random variable x and y respectively. Okay, first population, second population, random variable x and y. X follows Bernoulli, y follows Bernoulli distribution. And mean or the parameter is P1 here. And the parameter of population 2 is, say, P2, mean. That is mean. And the variance is here, P1, 1 minus P1. Population 2, P2, 1 minus P2, right? We previously studied this kind of a thing. Okay, X follows Bernoulli with parameter P1, Y follows Bernoulli with parameter P2. Variance X is P1 times 1 minus P1. Variance Y is P2 times 1 minus P2. And the hypotheses are P1 equal to P2 or P1 is not equal to P2. Okay, there is a difference. There is no difference. P1 equal to P2 can be written P1 minus P2 equal to 0. Alternative hypothesis can be expressed as P1 minus P2 is not equal to 0. Those things are equivalent. As we deal with difference between means, we did it. Okay, samples obtained from each population denoted as this way, x1, x2, xn1. From population 2, the samples is y1, y2, yn2. The sample sizes are different. Can be the same. The best estimator for P1 is P1 hat is summation xi divided by n1, P2 summation yi divided by n2. From this sample, we can get P1 hat and this one P2 hat, okay, respectively. Now, the test statistic for the hypothesis, this hypothesis, what is it? P1 hat minus P2 hat, right? Follows normal distribution with the mean P1 minus P2, variance P1, 1 minus P1 divided by N1 plus P2, 1 minus P2 divided by N2. You get it? We already actually studied it, and these are estimator, so random variable because x are random variable. So I denote it by bold, right? Bold. Estimate, then we simply P1 hat, not bold. This one is bold. You have to distinguish estimator and estimate. Okay, let's see. Then, same procedure for the hypothesis testing regarding the mean, same procedure will be applied. So, what is alpha? Alpha is a significance level. The probability of when H0 is correct, reject H0. Okay? This is what definition of alpha, significance level. But we studied 1 minus alpha in interval estimation. How we get the what? The formula. Standardized G. Standardized means this one. We have tested statistic here with the mean this one and the variance this one. So G gonna be P1 hat minus P2 hat minus its mean P1 minus P2 divided by what? It's standard error. Standard error is square root of variance 1 minus P1 N1 here P2 1 minus P2 divided by N2, right? This is G in this case. So 1 minus alpha is for confidence interval, okay? We use this formula G here, but in this case, what? In this case means test hypothesis test pre-assumption is H0 is correct. H0 is P1 minus P2 equal to 0. So it is given this formula. So what? G is here. Okay? This one. G, the same formula. Now P1 equal to P2. This one is given. H0 correct. So P1 equal to P2. So P1 equal to P2, then what? One unknown value, P. Okay? We don't need a subscript in this case. So instead of P1 and P2, I substitute P. P1 minus P, P1 minus P. Okay, here, this standard error of P1 hat minus P2 hat multiplied to every sector, then we get this equation. P1 equal to P2, so this value gonna be 0, right? So you have to note P1 equal to P2, it's P, substitute that thing into this equation, then we get this one. This one is for 1 minus alpha. Anyway, we have to estimate this value. Standard error of P1 hat minus P2 hat is square root P1 minus P over N1 plus P1 minus P over N2 should be estimated. How? P hat. Okay? In this case, P1, P2 are equivalent. So from here, X1 sample, Xn1, from second one, Y1 up to Yn2. So now P1 equal to P2, same, P. So we have to estimate P from this sample. So like a pooled estimator, okay? So X and Y's, X's and Y's are here. Summation xi, I from 1 to n1 plus summation I equal to 1 to n2 yi. Pull it, x and y, pull it, divided by total number n1 plus n2. This is like a pooled estimator of p in this case. You understand that? Okay? It is like a pooled estimator of variance. Okay, that is a difference. So rejection region for H0, it is for what? Confidence interval. So uh, outside of this range is P1 hat minus P2 hat. Test statistic is less than G alpha over 2 times this one, okay? Or P1 hat minus P2 hat greater than this value. This standard error of P1 hat minus P2 hat estimated by this. So now P hat is going to be here, okay? So you can get uh, you can get the rejection region for H0 like this. So the other thing is, if you have some example, then you can apply this result to get rejection region for H0. I think you better understand how it's going, the steps, procedures, okay? And this is the final section of chapter 5. I'm going to move to categorical data analysis. This is the, I think, this is the final stage of basic statistics theory. Next steps are statistical analysis method, categorical data analysis, and analysis of variance and regression analysis. Those three essential methods will be treated in my lecture. Okay, thank you. Bye.